Starbucks says their paper cups keep coffee hotter longer, so I tested it with a $5,000 thermal camera, and they're completely wrong. Watch this. The paper cup everyone thinks is worse, actually keeping heat in. The ceramic mug you paid $30 for, stealing your coffee's warmth 47 times faster.
Wait, what? I've been lied to?
And it gets weirder. Because what's happening inside your coffee cup right now is the same physics that powers hurricanes, tears molecules apart at 9 bars of pressure, and creates a vortex that NASA uses to predict natural disasters. By the end of this video, you'll never look at your morning coffee the same way, and I'll show you one simple trick to keep it hot 3 times longer. Let's start with the lie. Why does everyone think paper cups are worse? Because they feel cheap. But watch what actually happens. Same temperature coffee, same room, but the ceramic mug is hemorrhaging heat like crazy. The reason? One word: conduction. Ceramic molecules are packed so tight, they create a heat superhighway straight from your coffee to the cold air outside. It's like your mug is working against you. Paper cups? They're actually genius. Thousands of tiny air pockets trapped in the material act like microscopic insulators, blocking heat transfer. That's why Starbucks uses them, not because they're cheap, because they work. But here's where it gets insane. You know that metal spoon you leave in your coffee while scrolling TikTok? Watch this temperature reading: 185, 178, 170. That spoon just stole 15 degrees in 90 seconds flat. It's literally a heat vampire sucking warmth out of your drink faster than you can say oat milk latte.
My spoon is a traitor.
And it gets worse, because while conduction is robbing you from the outside, there's another thief working from the inside: convection. Hot coffee rises, cold coffee sinks,
creating these swirling currents inside your mug.
Like a miniature ocean constantly cycling your hot coffee to the cold surface where it loses heat to the air. And this exact same process, it's happening in Earth's oceans right now. The Gulf Stream, deep ocean circulation, all driven by the same physics destroying your coffee temperature. But forget room temperature coffee. Let's talk about how espresso machines create pressure so violent they literally rip molecules apart. 9 bars of pressure. That's what happens when you press that button on an espresso machine. To put that in perspective, that's 3 times the pressure in your car tires. We're talking 130 pounds per square inch, forcing near boiling water through compressed coffee grounds in 25 seconds. And at that pressure, physics gets violent. The force is so extreme, it's tearing apart the molecular bonds in coffee oils. When those bonds break, they release thousands of microscopic CO2 bubbles, and that golden foam on top of your espresso, that's not just decoration, that's crema, physical evidence of molecular destruction. Each bubble is a tiny prison cell trapping aromatic compounds and giving espresso that thick, syrupy texture that regular drip coffee can never achieve. And temperature? There's a 10-degree window where espresso is perfect. Too hot, you burn the delicate compounds and taste bitterness. Too cold, not enough pressure extraction, weak and watery. Professional baristas live in that 10-degree window. It's the difference between a $7 espresso that's worth it and burnt garbage.
So I just need 9 bars, right? How hard can it be?
Yeah, leave it to the $3,000 machines. But the physics doesn't stop once coffee hits your cup, because when you do this, you're creating a phenomenon that scientists study in million-dollar laboratories. And I'm not exaggerating. What you're about to see connects your morning routine to literal hurricanes. Watch what happens when I stir this coffee. See that spiral? That's not just pretty, that's turbulent fluid dynamics. The center spinning fast, edges spinning slow, creating chaotic, unpredictable flow patterns between the layers. And scientists, they literally use coffee stirring experiments to model turbulence because it's cheap, repeatable, and behaves exactly like the real thing. In fact, researchers at MIT published a paper using coffee stirring patterns to model hurricane formation. Same spiral, same vortex dynamics, same physics. Your $4 latte is mimicking one of nature's most destructive forces.
So I'm basically drinking a tiny hurricane?
Technically, yes. But while you're creating desktop disasters, something else is happening, something you can smell but never see. When coffee beans are roasted, heat triggers chemical reactions that create over 800 different volatile compounds, 800 different smells. Right now, these molecules are escaping your cup, floating into your nose, hitting receptors that send signals to your brain. And here's the crazy part. Change the roasting temperature by just 10 degrees, completely different molecular mix, different smell, different taste, different coffee. That's physics determining chemistry, which determines biology, your entire taste experience. It's three sciences working together in one cup. Okay, so we've covered heat theft, molecular destruction, desktop hurricanes, and 800 aromatic compounds. But here's what actually matters. How do you keep your coffee hot longer? 3 simple physics hacks. 1. Preheat your mug with hot water for 30 seconds before pouring coffee. This stops conduction from stealing heat immediately. 2. Remove the spoon. Seriously, we proved it's a heat vampire. 3. Use a lid, any lid, even a coaster. You're blocking convection currents from reaching the air. Do all 3, your coffee stays hot 3 times longer. That's physics you can actually use. So real quick, you just watched conduction steal heat 47 times faster, pressure tear molecules apart at 130 psi, turbulent vortices model hurricanes, and 800 compounds create smell, all in 1 cup of coffee.
I'm never drinking coffee the same way again.
You're drinking physics, chemistry, and fluid dynamics every single morning. But next week, we're talking about a scientist who drank radioactive water on purpose, and somehow that reckless decision saved millions of lives and changed medicine forever. If your mind is blown, smash that like button. Subscribe so you don't miss the radioactive water story. Trust me, it's insane. And comment what everyday thing should Blob and I explain with science next.